Hello, and welcome to the video in the ForecastBuilder training series talking about what is the NDFD forecast. This is Mike Dutter, the Science and Operations Officer in NWS Wakefield. So as we know, gridded forecasts have been part of NWS operations for nearly 2 decades. In fact, in the early 2000s, the NWS migrated from the era of text-based forecasts, like the ZFP, the Coastal Waters Forecast, so on and so forth, to a gridded forecast where grids from the GFE would mosaic together to form a National Digital Forecast Database, or the NDFD. The great thing about the NDFD is that it provided the ability to create point-based forecasts and to create more consistencies from WFO to WFO. So a lot of what you see in today's GFE and NDFD really connects back to this one-to-one migration. And it's why that weather grid that you see, that ugly weather string, is actually called an ugly string, in fact, that has all the details such as intensity, precip type, and probability. It's all contained in that ugly string, that weather ugly string. So when transitioning to text-based forecast to a gridded format, we also kept the same deterministic theme. This is why all of our gridded forecasts contain single forecast values like sky cover of 27%, pop of 34%, so on and so forth. But there is an important point, as stressed by the NDFD directive, that the values represent each grid box, not exact point forecasts. So even with the 2.5 kilometer grid spacing, there can still be huge differences across a single grid box, such as in areas of terrain, along mesoscale boundaries, and near bodies of waters. This, along with the scientific mismatches between pop, temperature, and QPF, are just a few of the number of issues with the deterministic gridded forecast. So, when you are forecasting, you know that certain grids and certain time periods have more uncertainty than others. But we still have to provide these as single forecast values. ForecastBuilder, following a deterministic approach, would take those single values and then help derive things like snow and ice accumulations. However, as an agency, we're moving probabilistically, and a number of examples are shown here, like NHC tropical track forecast, SPC outlooks, the probabilistic snow and probabilistic QPF experiments, and also the MBM, right? So seeing this example here, notice up top that we have temperatures forecast from the MBM in the 40s and upper 30s. However, if you look below, look at that probability of freezing rain. It's certainly non-trivial, right? It's in the 30s and it rises to 50% later in that forecast period. And you even have some ice accumulation noted there. So how can we take something like ForecastBuilder that is or was very deterministic and let it become more probabilistic? What we are about to show here is how ForecastBuilder is moving probabilistically while mixing in that deterministic data. Sometimes physically impossible combinations of pops, weather types, and temperature are the better forecast. So using this example from Dallas-Fort Worth for Tuesday night, which says partly cloudy with a 30% chance of rain and low below freezing at 28, that just wouldn't make sense. But we need to check out the meteorology. If you see this ensemble mean of the Canadian, European, and GFS ensembles, they would imply that the most likely forecast for the Dallas area is a clear, cold, and dry one, being in the wake of the upper trough. However, there is one cluster that comprises 30% of the ensemble solutions that is forecasting warmer temperatures with widespread rain. Given this setup, why should we be forced to mention freezing rain when it's just not depicted in any single forecast ensemble solution? And on the flip side, should we allow rain to be mentioned with freezing temperatures? And for that matter, how can we make sure that the forecaster just didn't inadvertently make a grid editing error? So the best course of action is to utilize the temperature probability data from the NBM. And so to demonstrate this, we looked at a graph of the 10th, the 50th, and the 90th percentiles of temperature during the time period of interest. ForecastBuilder can utilize this temperature envelope to determine whether the precip type is legal. Given the wide distribution of temperatures Tuesday night, ForecastBuilder would allow all precip types. But as this distribution shrinks on Wednesday and beyond, ForecastBuilder will restrict the type of precipitation that could be included in the grids. So when mixing probabilistic information, the POP, with deterministic forecast, like temperature, problems do occur, especially with precipitation accumulation near the deterministic melting threshold. If you let precipitation accumulation be sensitive to deterministic melting thresholds, say the temperature near 35, and have a probabilistic chance of precipitation and type, the end result many times is sharp, unrealistic gradients, as shown in this example. There are workarounds included in ForecastBuilder to prevent this, but the reality is that we really need to move towards something like what the NBM does, where it forecasts accumulation in area even when the most likely temperature is above a melting threshold. So when we mix deterministic and probabilistic data, this can produce a point-and-click forecast that seem wrong, like in these two examples. You see the tonight period has a slight chance of rain with a low of 28, and then on Friday night we have a chance of freezing rain with a low of 33, above freezing. In reality, and shown earlier, these situations are legit meteorologically speaking, and thus we must educate our public and core partners that these types of, quote, discrepancies can exist from time to time in the forecast. Ultimately, the problem lies with our single value point-and-click forecast, as they just can't communicate these situations well. Point-and-click forecasts just simply cannot communicate that complexity of especially when you have multiple precip types or multiple probabilities of precip types. You just can't communicate that complexity on its own. So in summary, given the various conditions that can occur across the 2.5 kilometer grid box, plus a varying degrees of uncertainty with the grids, the main goal when doing a deterministic gridded forecast is just to get in the ballpark. While grids do serve as a foundation for DSS, the actual DSS we provide can both fine-tune what the grids have, as well as provide confidence in alternative scenarios, which are things grids just can't do. Here are a few other articles and references worth reading regarding the NDFD and also some of the other topics touched on in this module. And as always, please reach out to us via our VLab site or by email if you have any questions. Thank you again for listening, and have a great day.